Okay, welcome back to Rust Hours. This is another video, and today we will start from where we had left. In the first video, we just got the feel of what the language is and what it feels like to code in Rust. And since I'm a beginner myself, we did make a few mistakes, and we also learned how those mistakes can be fixed. Today, we will be taking a similar approach. Unfortunately, I deleted the directory where I had kept the code. So let's start again from scratch. So I'll create a new directory under, wait, let me switch my screen and you should still be able to see me on the bottom left. Okay, so now we do not have Rust hours. So let's create workspace playground or maybe, yeah, let's keep it in the playground. KDI stars and CD rust. Okay. So what do we want to do now? Let's start from let's start from where we had actually left. We were talking about the main program, the very first program that you usually write in any language. So we learned that you can create something as simple as hello.rs and you can compile it using Rust C. I'll do a quick recap on what we touched upon. Okay, like any other programming language, Rust has an entry point, which is known as main. Um, fn is the keyword that is used to declare, okay, this is a function, and main is the name of the function that we are creating here, which serves as the entry point. I'll also quickly set or change the screen brush settings. I don't want an arrow, just want a simple line. Are we good? Yes, we are good. Okay. So in fn main, what we were doing is we were printing hello world. So println is a macro. Why? How do we know what's a macro? Anything that is, if the name of the function is followed by or suffixed with a exclamation mark, then this is a macro. Macros, as of now, you can think about them as special functions that are present in the standard library. Macros can also be created. We can define our own macros, but that's a very advanced thing. I have absolutely no idea how to create them at the moment. So for now, let's continue with that. This is a function that will print a string onto a standard out. How do we run this program? Okay. Using Rust C, we can actually compile hello.rs, and this gives us a binary, executable binary, which is hello. So, and we can execute it simply by typing hello, and that's our first program. Now, if you are doing very basic programming in Rust or any programming language, as for a matter, it's fairly easy to have your code in a single file and run it using things like Rust C. But if you're working on a larger project, for say, you need something more, and that more in terms of Rust is cargo. So I'll remove hello dot rs and hello. So what cargo is? Cargo is the project manager or the package manager. You can say it also helps you building. So it's a build system plus package manager for Rust programs. So if you installed Rust using the standard or not the standard, but the default page that we have for Rust language, you already have cargo. You can verify it with cargo version, I think. Yes. So ideally, you should already have cargo. If you don't, you can just go to the official documentation for Rust and you will be able to get it. Okay. There are a few things that I actually want to touch about cargo. Uh, so the way you create a project, let's say if you were to do a hello world in using cargo, you will do is cargo new, and you can say hello. This will create. Let me show you one thing. As of now, we do not have anything in this directory. So if we do cargo new hello, it will create a structure for us. And as of now, we have hello. Let's do a quick look into what we have in hello. So cargo by default uses Git as the version control system. You can actually override it with providing, I think, what you can do is uh, cargo new hello, and I think the flag is called VCS, and you can specify something else other than Git. As of now, Git is what it defaults to. So that's why you're seeing this .git directory. Let's start with again, since we are using Git, we also get a git ignore file, which has the target. We will talk about what target is. Cargo.tuml is where the cargo itself puts all the information that is required for you to manage your package itself. So under the package, this is a TOML format, TOML format, or I think Tom's minimal Tom's obvious minimal language or markup language, something like that. I don't really remember the full form. So this is the name of the project, the name of our executable that will be created. This is the version, and and then what we have is the addition of the. I think it's the version, not the addition of cargo specification, or rather the specification that is being used to draft this file. This dependencies is a collection of libraries or dependencies as we call them in the Rust ecosystem. All, and let's say if we were to depend on a library which gives you a functionality to um, straight away push things to a printer, that would be a dependency for us, and that could be added here. We will come back to these dependencies once we start building our application a little further. Now, we already talked about cargo.tuml, we talked about git ignore. This directory is where src is where the whole source code lives. So let's take a look at the src. This is main.rs, and this has the content of what exactly we had in hello.rs when we just started our application. So since it's a binary or executable that we are creating, this has a f in main. If we were to create a library, which we will at some point in maybe third or fourth video in this series, we will look at something in a way how we can create a library using cargo. But for now, we just focus on the binary. All right, so we have main.rs, which is where the whole code lives. And if you notice, as soon as I opened and saved this file, a cargo.lock file has been created, which should be nothing much as of now. So if you're coming from the background of I think Node.js or JavaScript, there is also a package.json, and then there is package.lock, which actually has the exact versions of the dependencies to which you want to lock. It's a way of reproducing the same exact executable, irrespective of when you're doing it over time and again. So this is the log file which will have the exit versions, and we will revisit it once we add some certain dependencies. So we can close this. Yep. So we have looked already at cargo new. The next thing I want to show is cargo check. Cargo check actually what it does, it will check your program and it will see if there are any build errors or there potential build errors or any warnings or any issues. Let's say if I create another function, let's say call it foo, and it's not being used anywhere. So if I run cargo check, it will tell me that okay, this is the foo function is not being used. It's a one dead code. It's not being used anywhere. So that's what cargo check does. But it does not build your application. It only compiles it. How do we build our application? We build it. Let's clear this. We build it using cargo build. So now we have our application built, and as you can see, uh, compiling. Oops, let's not. Yeah, the information I wanted to show you is compiling hello. This is the version. This is the name of the package that we were creating. This is the version that we had in our cargo .toml file, and this has been built. And if you notice, this has been built for Dave profile. So what does that mean? Cargo builds for two profiles primarily, and I think they are only two profiles: Dave and release. What this means is when you're in a rapid development phase or when you're building locally, um, what you need is a lot of debug information that you need attached to your binary so that it's easy for a compiler to give you information when it's when where the issues are. So that's what Dave profile is for, which is a default profile until unless you tell cargo that you want to or build for a release profile. Now, let me show you something. Source is again where we had our files, and since the my UI is actually respecting the git ignore, so let me show you here. There is a target directory that has been created for us, and if to we do a target, you see a debug directory, which is where the Dave builds are kept. And if you see under target debug, there is an executable present which is called hello. And this is exactly where if we were to release or build it for cargo build hyphen release, if we were to build our application for release profile, we will see that it says that the profile uses release and it's optimized. Initially, when we built for the Dave profile, it was unoptimized and it had debug information. So that's a primary difference. This is actually this is something that you can actually configure your steps or what you want to do specifically when there is a profile in execution. They If you look into the cargo documentation, you get a lot of configuration options for your profiles. This is what I want to do. This is I think you can actually remove certain um, debug information or flags that are or symbols rather that are added to your binary. You can trim it further in your profiles, and I think that goes hand in hand with other programming languages as well. So if we look under target again, there are two directories, as you can see, debug and release, one representing each profile. And I think if you look at the size, target debug, the size here is 414 KB. Okay, for the hello binary. And if I'm not wrong, it should be smaller for the release. Yeah, it's a bit smaller. Still quite a lot, but smaller. And that's what I meant. Like you can actually further reduce this using certain flags or symbols being removed in when cargo builds your application for, say, release build or release profile. Okay. So we have seen cargo check, we have seen cargo new, cargo check, and we've also seen cargo build. The next thing that I want to talk about is cargo run. How do we run this application? So if we, the easiest way to do is, or rather the traditional way to do is, since we have been using the one, we can actually run it like this. But there is a better option, which is cargo run. This will run our application straight away. If we had changes in our application, then we should also be able to, let's say if we change to from hello world to say hello rust, and now do a cargo run without doing a cargo build, it will actually go ahead and it will detect that there have been changes since the last build. It will build your application in the dev profile and run it straight away. Okay, think that does for what I wanted to cover in terms of cargo. Let me quickly check if there is something that I moments more. Mhm. Okay. Yep. That's quite enough. Okay. Let's start with something for today. You can exit. Now, I would actually like to align with the Rust programming language book. If you have not seen the book, you definitely should, and you should definitely follow the book. If you simply search for Rust book, oh, not Bool, Rust book. So this is a great place to start for anyone, and even in fact, I'm also reading it. So as of now, we have just got an introduction of the language. We've also talked about cargo. We did a hello world. So let's start with programming a guessing game. I'll keep the book on a separate screen that I have, and so let's start building something. This can stay here for now. All right. So okay, so we start off by creating. Okay, one more thing. We talked about cargo new, we talked about cargo check, build, and run. But what if you had already started a project and you were not using cargo? And let's say if we were to do, let's do mkdir guessing, uh, guess a number, guess number. And if we were inside guess number and we already had, say, main.rs, how do we convert this directory, which is as of now it's a plain directory, to a cargo supported project structure? What we can do is actually go ahead and do cargo init and pass in dot, which means the current directory, and it should be able to convert it into a structure that we can use further. Now the problem is it only created a cargo.toml. It does not create the source directory. That is something we'll have to do on our own. So we can, oops, what did I do? Okay, I think I messed up somewhere. Anyways, let's get into guest number. What we can do is mkdir src, and we can move our main inside src, and I think we should be able to do cargo run. Nope. Could not compile due to a previous error. No such file or directory. Guess number. Interesting. Oh, so what's happening is, if I understand it correctly, so Cargo assumed that the binary that we're creating is called guest number, and we will have a separate directory inside inside our root directory. So if you remove this, and now we should be able to build oh, some more errors. Mm, This is complaining because there is no main function. Fn main. Let me show you the error once again. So it says main function not found in create guest number. So let's fix it quickly, and we should then be able to compile. And here we go. So we are compiling, and we are also able to run. So what this is all about, invalid offset. I think I'm going to have to restart my Vim. Just so Rust Analyzer is at peace. Okay. What we want to do is let's build a small application which will, what it does is we prompt the user that uh, guess a number, we will internally and then the user will actually input a number. Let's say they said 10. We will internally generate a random number which is our secret number of some sorts. And let's assume we want to generate a number between 1 and 100. Next, what we want to do is we want to compare if the guess is greater than the rand or the secret number, or if it's a smaller than um, if it's smaller than the secret. If it's equal to the secret, we just say, okay, you have guessed the number. That's what you want to build. Greater than slash less than slash equal to. Uh, you got the idea at least. Let me wrap it in this form. Not the best way to represent, but you got the idea. And um, we would also want that once the guess is correct, you should let the user know that you have guessed it right, and there should be multiple tries, multiple attempts the user can make for the guess to be uh, like I guessed a number, say 10, but it was too low. Then I would give another attempt to the user, guess again, and it would say 20, which is too high, which means somewhere the number is between 15, and it keeps on going on. So maybe in infinite, infinite guessing. So this is what we want to do. All right. So where do we start? Let's start with printing a number and guess this. And such so we know that okay, our application is actually running. Guess a number. And we have guess a number. Okay. Okay. So how do we so ideally what we want to do is as we saw the prompt guess a number, the user should be able to input their number on the new line. So how do we achieve that? Let's start off by scanning. I'm not looking at the the documentation is in the Rust book. I would prefer to do it in a way that you folks can also follow going forward. Let's start with standard.rs. What you want to do is you want to scan the lines, or rather, I want to read from the standard console, standard out, standard in, not standard out, standard in. You want to read from standard in. So there should be a handle to the standard input stream of a process. Okay, constructs a new handle to, this is so confusing. So this is a struct, this is a function. So probably we need this one. Constructs a new handle to the standard input of the current process. Okay. Each handle returned is a reference to a shared global buffer whose access is synchronized via mutex. All right. So just we should still be able to do something like this. So what it's doing is it has a buffer, a mutable buffer. We will see what that means. Okay. So what we need to do is we need to import standard IO and say let guess equals IO slash standard in. So this portion gives us the handle to the standard input, and we can do read line. Okay, it needs a mutable buffer. We need to store it like that. So this needs to change. If from the previous video, you should also remember that the way to create a string is using string new or string from. We can do string from, like create an empty string, but we can also do, if we want an empty string only, we can also do a string new. This will also give us an empty string. Now what we want to do is scan the new line or read the new line and store it in guess. So you can think of it like I'm passing the address of guess to the new line function and say whatever you read, put it in guess. Now there are those linings, and that this line underlining and this handle right here means there is an issue. Um, the Rust analyzer says expected a mutable string, but found a reference to a string. Mismatch types. So this needs a mutable reference to this string. So okay, let's take a step back and see what's happening here. What we did was create a string. This is a string that we have created. This returns us a string. Strings are stored on heap and they are growable. So which means if we want, we can add anything that we need to into our guess string. Okay. But for that, the guess needs to be this needs to be mutable. What that means is, in a last video, we also talked about the mutability and immutability. So if we were to have let x equals 10, this means that there is a value 10 which is being assigned to the variable x. Since we do not have x declared as mutable, by default it's immutable, which means at any point in time later in the code, I cannot say let x equals to 20. This is a compiler issue, compile time issue, and and you can already see that it's actually complaining that you cannot do this. It's not being declared as a cannot mutate an immutable variable. So by default in Rust, every variable is immutable until and unless you explicitly tell the compiler, but that this needs to be mutable, and I plan to change the value later in the code. If we set this as mutable, this should be absolutely fine. So it's just a warning that the signed value is never used. Just fine. So let's remove this. Let's remove this. And, so we are creating a string at this line. What we want to do is to be able to change this and set or assign the value of whatever we read from the line and store it in the guess. So needs to be immutable. But okay, so we have declared guess as mutable. Then why are we still getting this line here? Let's see what's the issue. Expected a mutable reference and we got a string. So in Rust, not just the variables, but the references are also immutable by default. Meaning, if we have something as like x equals 10 and let y equals reference to x, and later at some point I will declare let z equals 9. Can I do y equals to z, address or reference to z, whatever you want to call it? Can I do this? It seems so. At this point, no, it was not complaining because of the error below. So as variables are immutable, references are also immutable. We can do change this if we declare that y is going to be a mutable reference of z. And now it's complaining that this is not it's being overwritten, value is never assigned. So we need to explicitly say that although we are passing a reference to oh, in fact, wait a second, I actually used an incorrect example. So this is just making y to be mutable. Actually, this is an incorrect example. This needs to be something of this sort. That z now needs to be mutable. Yeah, yeah, yeah. Okay. I think I need to come up with a better example so that I can explain mutable references and immutable references. Um, I think this can be very well covered or talked about when we talk about functions and yeah, like passing a value to something. We will revisit this one. This is an interesting one. Okay. So as of now, I can tell you that if we look in the signature, it says that fn read expects a mutable buffer. Here we go. It requires a mutable buffer of mutable buffer, which is a mutable string. So let's change this to be mutable. And now there is a complaint, unused result that must be used. So it's returning a result. Now, what is a result? A result, if I may use this space. So result is an enum. You can actually, instead of thinking about it as an enum or enumeration, think about it as when you do certain operations, even in your daily life, whether it can be either successful or it can fail. In very similar way, Rust takes a very similar approach. It says the result of your operation can be either a success or it could be an error. So it translates those into enum variants. So result is an enum which represents the state of your operation, whether it was successful or it failed. It can either be okay or it can be an error. And both of these will hold the actual value. I'll I'll tell you what this means. So if your result was successful, we will actually hold the value that was generated as an output of that operation. Otherwise, if it was an error, E will actually hold the value of the error itself. Now, at this point, we do not want to get into what um, this error handling part. So result has is an enum. It actually, you can think of it as any value, and it has certain methods attached to it. So what we can do is we can use either unwrap, something that we did in our last example also, where we would kind of received a gift on Christmas, and you just unwrapped it irrespective of whether it's just a prank or it actually contains a gift. So that's what we were doing. But there is a better way. We can use expect, and expect, what it does is that it's returns the content okay if there is a value, um, and if there is not, consuming the self, if there was an error, it will return a message along with the error. um, Incorrect, or let's say, and now we should have the guess stored in the guess variable. So we can say this is string interpolation. And I'd also like to tell you that in the curly braces, you can pass variables or things that can be known right at the compile time, or which are um, which are not expressions, I would say. Um, you can just straight away go with scalar values or variables which are pre-assigned, sorts of. There is a term that they use to define it better. I'm just totally missing it. Okay, so as of now, if we run our program, guess a number, say 5, you guessed 5. So we're getting 5. Let's run it again. What if we do guess this? Okay. Oh, interesting. So if you notice, we are actually you're actually guessing a number, and I just input ASDF, and that was accepted as a something that you guessed this, which is incorrect, right? We should be able to just be sure that okay, this is going to be a number. We'll need to fix that as well. All right. So as of now, we have a guess, and so what do we want to do next? Whether we want to generate the number itself, or we want to, yeah, let's generate the number. So for generating a random number in Rust, there is no built-in create or library or path binary as such that you can use to generate a random number. You will need to rely on something outside. Explain this. You need to rely on an external library, and I think, and now I look at the Rust book, how they are bringing in the variable. I think that's there is a rand create. Um, okay, yeah, this is the create rand. So instead of pinning it, we can actually pin down to this as a dependency. But there is another way you can, if you're not really concerned about the version of the binary or the dependency that you're bringing in, what you can do is use cargo and RAND, or let me show you something interesting that I found very recently. You can actually search random as a string, and this will give you all details about which crates are available. So this is the crate that we want to use. So let's add it. Let's go add, and now we have added um, our first dependency. Let's quickly take a look at the cargo file, because we just added a dependency. So let me open that. So RAND, this is the, okay, so the latest one that we can use is 8.5 only. So we just added a dependency to our application. And now if we build it, you see there are a lot of dependencies that RAND depends on. So those will also be pulled in, downloaded, and built when we run or build our own application. Interesting thing now is if we look at cargo.lock, you see there will be multiple packages or dependencies that have been pulled, which we had no idea or we have no straight connection to. These are all dependencies that are being pulled in just because we pulled in one dependency called rand, and somewhere we should have rand. Yes. At the same time, if you look at cargo TML, we just have one dependency, which actually depends on multiple crates. They are being pulled in. All right. Okay. So now what we want to do is you want to build or generate a random number using the random crate that we have just pulled in. How let's go to, oh yes, one more thing. Think it is called cargo doc. Um, There's a command that you can use to generate the cargo documentation, the documentation of the dependencies that you create or yet that you depend on. But and there should be much more flags to it. Like you can straight away host it. Okay, run hyphen offline. Yeah, same thing. How do I open it? Or have they shared? Um, I think I have it saved somewhere. That's what I'm looking for. There was a uh, cargo dog hyphen open. Okay. Yep. Like you don't want to go to the file and then open it in browsers. It should be able to open. Yes. That's what I was looking for. So these are all the traits that we have pulled in as a dependency. We just saw them in our cargo.log file. So if we open rand, this is the this gives you the documentation of the dependency. So you can just read through it and see how we can actually use it. So as of quick start, to get you quick started quickly, the easiest and highest level way to get a random value is to use random function. Alternatively, you can use thread range. The RNG trade provides a useful API on all ranges, while distributions and sequence modules provide further functionality on top of RNGs. They do not have a very good documentation, I would say. Not easy to follow, I think, or maybe I'm not following it very correctly. Okay, so they have an example right here only. So it says random dot thread range. I'm a little confused. Like, what does it return? Thread range. What is it? Okay, this is a reference to the thread local generator. Okay, so that should be thread safe, I think. Okay, I don't fully understand uh, why and how this will be super useful. Let's go with the flow. Because I want to generate numbers in a certain range, prefer to go by this. What does the Rust book do? Mhm. Okay, so they are also doing the same thing. You go with the thread range, which gives you a thread safe, or for the current thread, they will generate from this particular range. So let's do this only. So, okay, what the issue is, get gen range found no method named generate range found on this struct in the current scope. And this is happening because in Rust, you need to bring in the in scope the crate itself. So I think, yep, this is RCNG. Now we should be good. Yes. We quickly see if they have okay, so it says first we add the line this. The RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use methods. Following chapters will cover in detail. Okay, and since we wanted to go from 1 to 100 being included, that's why we have used equals to. Does it allow us to use without equal to? Yep, I think it does. Okay. Now let's print what we are generating. And I think you already must have noticed that we use snake case in Rust for variables, and same goes for functions as well. In many languages, we use camel case, but in Rust, we use snake case. And at this point, I don't want to continue. I just want to return. "36" is the number generated. 29, 64, 97, 85, 16, 12. Fairly working. Okay, now that we have our number generated, the next step, um, okay, we have our number and we also have our guess. So, but the problem is that our guess is actually in string and our number is a number. See what does it return. Generate range, it returns 30, it's generic. Okay. So we can actually have it of any type. We can actually convert it into an I32 or a U32 of whatever we like. So Rust supports, as far as I know, Rust supports multiple types of integers, I8, I16, I32, and I64. And same goes for U32 and U8 and all. By default, it goes to by default it's I32. So this should be, as of now, uh, I32, unless we explicitly say that it needs to be a U32. That should still be okay. But I don't want to set it to anything as of now. Okay, so the next thing that we want to fix is, since we are getting a string, what we need is to be able to parse that string into a number. And the way we can do it is, like in any other programming language, we want a U32 number. So we call it parse, and it should take in, does it take the number itself? And I think it would be a good point or good place to use shadowing. So I can say that guess equals u32 dot parse, and should be able to parse from guess. Okay, let's go to standard documentation for a bit. U32, there should be a function called parse. No? Okay, so it's stir.parse. Okay, not the other way around. Oh, all right. So we need to specify the kind of or the type that we expect and then you do this. Okay. So what we want is to guess to be U32 and guess dot parse. Now let's steps back a second. You must be thinking, or you may be thinking, that we have guess declared right here, and how come we have show toolbar? How come we have redeclared guess? So this is a concept of shadowing. This guess will shadow this particular guess, this guess right here. So going forward down the line, this guess will be considered as in scope, and this one dies with this one. This is called shadowing. Any amount of code that goes in between these lines, like line 5 and line 13, for that, guess is a string. For any line after line number 13, any code or line after 13, the guess is U32 integer. And as you can see, the way you tell the type of a variable is, or define the variable type is using colon. This is how you do it. So guess dot parse, and it's failing. Why? Because it also returns a result. And since we have already handled one of the case with results where we use expect, likewise, I'll say expect fail to pass your guess. And this should give us the number. Okay. So far, so good. Now, the next thing that we need is to be able to compare those two, the secret number and the guess that we have. For that, um, let's keep it here only. If it fails, we don't want to, we actually want to print. Okay, so there is a CMP trait that we have in the Rust standard library, I think, which gives you a way to compare different types, which are comparable types. Standard compare utilities for comparing and ordering values. This module contains various tools for comparing and ordering values in summary. This is the summary. So ordering is an enum returned by the main functions of order, and this and describes an ordering of two values, less, equal, and greater. So this is what we're interested in. Okay, how do we use ordering less? Okay, Do we have an example at the top? Nope. Is there a function called CMP? So, so these primitive types, U32. So we converted our guess to a U32, and this U32 should be implementing that comparing trait. Uh, Trait implementations, and if it has CMP, we should be good to go. No, 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 no. Oh, not comparing, ordering. It does implement order. So the function CMP is present. So, which means what we can do is guess dot CMP, and it takes in a self and a reference to the one that you want to compare with. Okay. Yes. So you want to compare guess with the secret. Secret number is a little too much to type. Anyways, it's almost over. And what does it return? It returns an ordering, which is an enum. And I think what we can do is use match expressions. Match this. So what is match? Match is much like a switch case, but with certain differences. One of the key differences that I would like to touch upon here is, let's say if you're writing a switch statement in a language, it does not force you to cover all the possible scenarios. You can just add one and be done. But in Rust, we have match expressions that forces you to cover all possible combinations or all possible outcomes. Those outcomes, as of now, as we will see, that they are called as branches. So match expression, what we're doing is we are comparing guess with the secret number, and there are three possible outcomes. And these are expressed in terms of um, an enum. What that enum is, this ordering enum, it can be less, equal, or greater. So here is an example. We are comparing 1 with 2, which means the output will be less because 1 is less than 2. If it's same, it's equal. If it's 2 is on the left one, the one we are comparing on is greater than the one we're comparing with, then it will be greater. So we have three branches to cover. There are three possible outcomes that are possible. Uh, Less. If it is less, what we want to do. If it's equal, then what we want to do. And if it's greater, then what is it that we want to do? and it's complaining that it's not there in the scope. I think that should be there. Fail to resolve. Yes, this is because we have not pulled it in, and the way to pull it is use standard CMP RDIG. Yep. So for now, maybe let's just print to list and oops. Okay, so we are handling three possibilities that can happen when we compare guess with the secret number. It can be less, it can be equal, or it can be greater than that. Um, so let's try and run this. Guess a number, say 65. Okay, so the third man main panicked because uh, failed to parse guess, parse int error, can't invalid digit, we're able to display a backtrace. Something is not right with our code. Mm, uh, is it that we are not trimming things from? We're actually doing it right. We are passing it, and if it failed to pass, it would have complained. Something else is going on. Stars. Is it that that's line number 16? Let's quickly check what's happening on line number 16. Failed to parse guess. So maybe it's actually taking the maybe it's taking the slash n with that we have the carriage return at the end. Or maybe it's taking that as well. Let's see. Okay, so that was the issue. So yeah, I think this errors like these, hiccups like these are exactly the sole reason why I started doing this series, because I am also a beginner, and it's very common to fail in such scenarios. Um, cool. It's good that we ran into an issue, and I just remember that maybe when we put in a string into console, then we do slash press enter or return key. There is a slash n carriage return added, not a slash r that is added to the string. So that's why we need trim, which will trim from the beginning and the end of the input any s- new line characters or slash kind of characters and any white spaces. So slash r, the carriage return, is also a sort of white space that will be trimmed, and then we will be able to parse it. All right, so we have almost achieved what we want to do. Now, only thing that we want to now fix is that if the guess was too low or too high, we want to give our user another chance, and instead we want to keep guessing until unless we actually meet the secret number. To run, which means we need to loop, and the way to do it in Rust is using the loop keyword. Loop is looping infinitely, or is so common in certain scenarios or different scenarios that it actually Rust also introduced a specific keyword for it, that we loop forever. And what we now do is we start the loop, we guess a number. Okay, so we generate a secret number, we say guess a number. In fact, we should be guessing in within the loop. This all should be happening within the loop now. So when the loop starts, we guess a number that is stored in guess. We parse the number. We also print that you guessed it. You get the number. Guess is this. Or in fact, we can actually just silence it for now. We parse the number, and then we do a match. If it's too low, we continue, and we say you need to continue. And if it's equal, you guess it right, and we should break out of the loop. If it's too high, we again continue. Seems to be correct. Guess a number, say 5. Too low. Guess a number, say 45. Too high, say 30. Too high. What about 20? Still high. 15. Too low. Is it 18? Too low. Is it 19? Woo! Yay! We get a good run. All right. So what if I run it and I guess say 26 numbers, but I don't want to continue. I can always press Control C, or yeah, I think that should do. Yep, that's our first good working game that we have created. All right, I think I'm gonna stop here. It's been already almost an hour, I think. Okay, so if you have any suggestions what I can improve on the stream, if I should prepare upfront a little more. I do intend to keep it as raw as possible, fail on the stream itself or on the video itself, and then figure things out on the fly, think about it, so that you also get to have a real feel, and I also get to experience it first. And like failures can happen anytime. I don't want to be too prepared about this, but if you have any suggestions, do leave them in the comment. And if you would like to see more such content, feel free to subscribe and share it with anyone who might find useful. Thank you. Bye bye.